Hello everyone, welcome to my channel. I hope you all are doing great. In this video, I shall be explaining how to run the ordinary least square model and how to obtain the descriptive statistics of a data set using STATA. So let's get started. First of all, you need to open your STATA application and afterwards, you need to first import your data file. So my data file is in Excel format, and for that, you need to click on File, then scroll down to this option Import. And if your data file is in Excel format, you need to select this option Excel spreadsheet, right? And then browse your file, select your concerned file, and then click on Open. All right, so you can see this is my data sheet, and Stata is giving you a preview of the same data sheet. And you can see the name of the variable list is appearing in first row. So you can remove this by checking this option of import first row as variable names, right? So once you have done this, you can click on OK, and you can see the data file has been imported in Stata application. Okay. Now, so I have a list of variables. In the right pane, if you can see, this contains the name of all the variables which are listed in my data sheet and the label. Okay. So I have set of few variables wherein there is one dependent variable and some set of independent variables. So the dependent variable in my data sheet is CO2, and the independent variables are Y, which is here for GDP, then energy consumption, population, and trade openness, right? So I have these variables in log format. I did the log transformation of the variables in the Excel sheet itself, and then you can see ln CO2 here is the log of the dependent variable. Likewise, you can have a look. I have converted all my independent variables in the log. So I have a list of all my independent variables in log format also, right? So first of all, we need to identify the type of data set that we are dealing with. So this is a panel data set, and I need data to recognize this fact that I have imported a panel data sheet, right? So for that, the command is xt set id and time. Okay, so xt set here is the command for panel data set. ID here represents the cross sections. So the cross sections in my data set are being identified by this label country, and the time in my data set is being identified by this label year. Okay, so accordingly, I'll change the command. So XD set here is for the panel data, and next is the cross section, which is country in my data set, and time here is being represented by year. Okay. And also, since I'm dealing with an yearly data set, so I'll put yearly post a comma. Okay. So this here is the command for panel regression data sets structurization in the STATA application. So as soon as I enter this command, and then you can click on enter. So you will see over here, now STATA has identified that the Excel sheet which has been imported in the application, it is a panel data sheet and it is strongly balanced. The time variable that is being identified by this label year is from 1990 to 2019, and delta is 1 year, right? So once you have done with this command, so this is the foremost step while dealing with regression analysis in STATA. Of regression coefficients using the OLS model, we need to understand the statistics of each of the variables included in the dataset, right? So for that, we obtain the descriptive statistics of a dataset. I have already uploaded a video on what is descriptive statistics and how to interpret descriptive statistics using eviews software. So here I shall be explaining only the procedure of how to obtain the descriptive statistics in case you are using STATA application, but in order to understand how to interpret each of the descriptive statistics, you can refer to my video on how to interpret descriptive statistics. For your convenience, I have also attached the link of the same video in the description box. So do watch that video. So coming back to this one, there are various ways to obtain the descriptive statistics of a dataset. If you want to obtain just the basics of descriptive statistics, then you can always use this command summarize. Okay, summarize will provide you with the basics of the descriptive statistics of each of the variable. If you want to obtain descriptive stats of a particular variable, you can mention that variable after this summarize. And if you want the descriptive statistics for all the variables, you can keep it as it is and then click on enter. So you will see over here, this is the list of all the variables in the very first column. In the second column, we have the list of number of observations, which is same for each of the variable, obviously. Then we have mean of each of the variable, standard deviation, minimum and maximum value of that particular variable during that time period. Okay. Now, there is another way to obtain descriptive statistics, and we can also obtain the skewness, kurtosis, arithmetic, harmonic, and geometric way. So, if you see in the top panel, there is an option of statistics, right? So, instead of using commands in Stata, you can always refer to this top panel in order to obtain the descriptive stats of your variables. So the first option here is summaries, tables, and test. Next to this one is summary and descriptive statistics. And if you move further, the last option here is summary statistics. So if you click on this option, you have got a dialog box wherein this option provides you to select a particular variable. If you want to obtain descriptive stats for a particular variable, you can select that and you can also select more than one variable here, right? You can see over here, I can select as many variables I want, and after this selection, you can select this option standard display. Standard display will again provide you with the same set of descriptive stats that has been obtained using the command summarize. Okay, we can have a look on this using the standard display option and you can click on OK and you will see over here, since I selected only these four variables, that option provided me here with the descriptive stats wherein I have got the mean, standard deviation, minimum, and maximum value. Now going back to the same option of statistics and moving forward again to this last one, summary statistics. And now instead of standard display, if you select this option, display additional statistics, And then you click on OK, keeping the set of the variables same in this box. Click OK. All right. So here you will see, apart from those four mean, standard deviation, minimum and maximum value, here you have got a list of percentiles, smallest value, variance, skewness, and kurtosis. Percent, skewness, and kurtosis. Now, if you want to obtain the geometric, harmonic, and arithmetic mean of these variables, then you can scroll down to this fifth last option of arithmetic, geometric, and harmonic means. Okay, so here you can select your variable for which you want to estimate these means. Suppose I select GDP over here, right? And confidence level here is 95% by default. So I'll proceed with the same and then click on OK. All right, so you can see over here, this option gives you the arithmetic, geometric, and harmonic mean of the variable GDP. The total number of observations here are 210, and then we have the 95% confidence interval, and the mean value is this. So arithmetic mean is 6.87, geometric mean is 6.80, and harmonic mean is 6.74, right? So this is how you can obtain a set of different descriptive statistics that kind of gives you an aerial view of your data set. Okay. Now, if you want to run the OLS model in order to estimate the regression coefficient, the command to run the ordinary least square model here is reg for regression, and then select your dependent variable followed by the list of independent variables. So in my data set, I am dealing with three independent variables. One is LNY, that is log of GDP, and then log of energy consumption, and the last independent variable is log of population, right? So the command here is very simple to run the OLS model, that is REG, which means running the regression. Okay, then click on enter, and you can see over here, STATA application will provide you the results of regression coefficients obtained using the ordinary least squares model. Okay, so you can see over here, the number of observations are 204, F statistics with 3 degrees of freedom, and 200 observation is 41.49. Probability of F statistics is greater than F. So here we have the probability F statistics less than 5% level of significance. It is here 0.00. The R square value is 0.38. Adjusted R squared value is 0.37. And root mean square error is 0.54. Okay. Then coming down to this table, we have the list of variables. The second column, we have the value of regression coefficients or the elasticities, right? So for GDP, the regression coefficient value is 0.79. For energy consumption, it is minus 0.89. For population, it is 0.104. And for the constant, the value of regression coefficient is minus 1.42. In the third column, we have the list of standard error for each of the variables. Then we have the t statistics value and the probability of the t statistics. And last columns gives you the 95% confidence interval, right? Now here, how do we interpret the results of the regression coefficients obtained using OLS? If we look at the first variable, that is GDP, the value of regression coefficient is 0.79. That means that ln increases by 1%, carbon dioxide emissions will increase by 0.79%. Okay, coming to the second one, if LNEC increases by 1%, carbon dioxide emissions reduces by 0.89%. Reduces because here we have a negative sign for the regression coefficient. Coming to the third one, that is population. So if the population increases by 1%, carbon dioxide emissions will increase by 0.104%. And lastly, we have the regression coefficient value for the constant, right? And to find out whether these regression coefficients are significant or not, we look at the value of the t statistics. The probability value of t statistics, if it is less than 0.05%, then we conclude that all the variables are statistically significant. So if we look at the probability value of first independent variable, it is less than 0.05. For the second one also, third and the fourth one also, that is for the constant. For each of the independent variables, the probability value of the t statistics is less than 0.05, and it is even less than 0.01, that is 1% level of significance. So we conclude that each of the independent variable have a probability value less than 0.05, and hence all these independent variables are statistically significant, right? So model in STATA. So I hope now you can effortlessly pull this out, and you can also join my Telegram channel, and the link for the channel has been attached in the description box. You can raise your queries and doubt there also, and you can connect with me on Telegram. Thanks for watching. Have a great day.